So yeah, I'm going to be talking a really pretty brief overview of what the hands-on sessions are going to be like here at Sagan Summer Workshop. So very briefly, this was already covered earlier this morning. We'll have one hands-on session today where we'll go through some JWST data analysis. Tomorrow, we'll go a little further along that. Wednesday, we'll have a hands-on session about forward modeling with PICASO, and another one following that about retrievals. And then Thursday we'll have group projects, and then Friday we'll have final presentations from those projects. So a brief introduction to each of these. Hands-on session one is one that I worked on. And it's about going from JWST data from raw pixels to a light curve. So how do you measure a transit? So JWST data, this is a MIRI image just for an example. It's kind of convenient because it's vertical and it doesn't take up that much room. You have your star in the detector is this bright region in the middle here. And so that's one image. Okay. Hopefully people online can see it now. So yeah, you have this light on your detector and you have basically an image of the spectrum of the star planet combined light. But you don't just have one of these, you have typically thousands or tens of thousands of these images. And that's a lot of information. You can't just do something easy with this. You have to do some processing. So basically what you do is you kind of sum in the spatial direction, which is the x-axis of this image, and then you go from a three-dimensional thing to a two-dimensional thing, which is like wavelength and time, and then you're measuring how the brightness of the system changes. And so, yeah, here you can see there's an eclipse in this case. So you see out of eclipse, then in eclipse, and then out of eclipse. And you can see basically the eclipse depth as a function of wavelength. But again, this is still a lot of pixels, even just in this figure. We got to boil things down so that we can actually do something with it. So typically we'll kind of chunk it up into these little well-defined regions and say, okay, we'll just combine this down into a collection of 1D light curves. So just what is the function of light as a function of time? And then we'll do that for different wavelengths. So this is going to be the project one. You'll have two choices, and if you're quick, you can do both, or if you're really quick or eager, you can do one or both, and then dive really deep into them. So one option is to look at the MIRI eclipse of WASP 43b. The other option is to do a near-spec transit of WASP 39. That then flows into hands-on session two, where we'll be fitting those light curves. So now we have a measurement of what the light does as a function of time, but what does that tell us? What is the system doing? So for this, we do fitting. So we fit the light curve as a function of time with a collection of systematics and astrophysical models. And again, we do this not just for one wavelength, but for many different wavelengths. And we can measure, say, what is the eclipse depth as a function of wavelength. And that then gives you an eclipse spectrum or an emission spectrum. And so again, for workshop two, you can either switch. If you did near spec for one, you can do MIRI, will give you the inputs that you need, or for both, you can do both. Yeah. Then to get into interpreting this, like you'll see that, oh, there's this bump here. Oh, this cursor is confusing. Yeah, there's a bump in the near spec transmission spectrum, and there's like this low point near 7 microns in the MIRI emission spectrum. What are those? To do that, you need to do these kind of forward models and retrieval models that we've heard about earlier today. So hands-on session 3, this will be Wednesday. We'll have a forward modeling session with PICASO led by Natasha Batala. So you'll go from looking at this WASP-39 near spec prism observation of the transmission spectrum. And then you'll do different things like plotting what do different molecules look like, kind of what we saw earlier today, and say like, oh, CO2 has a bump here, maybe that's the molecule I'm seeing. And you'll do kind of different things of seeing how does metallicity, how does carbon to oxygen ratio affect my spectrum, what do I think my atmosphere might be made out of. The second session on Wednesday is using retrievals with petitRADTRANS led by Paul Malliere. Here, this one is broken up into two different notebooks. The first is kind of calculating spectra with petitRADTRANS, and so this is kind of just like getting familiar with the tool. And then the second one, you'll work on a transmission retrieval of WASP-39 near spec G395H transmission spectrum. And so one important thing to note about all of those hands-on sessions is that there are like single preparatory notebooks that should be run in advance. So especially for today's, in the next hour or two or during the lunch break, if you can, you should run the like preparatory notebook, because that'll download stuff into your Google Drive. And it's like a couple gigabytes for some of these things. So it's better if you do it early, because otherwise you'll waste a lot of time just sitting there waiting for a little spinny wheel to finish. That then takes us to the group projects, which will happen on Thursday. These are opportunities to dive a little deeper into all of these projects, and you'll work with a group of people yeah, try and push beyond what we kind of held your hand through and see what you can learn for yourself. So the first group project is to investigate more thoroughly the near-infrared transmission spectrum of WASP-39. So in the first hands-on session, or first and second, you'll have worked on near-spec G395H NRS2, which is the right half of this bottom left panel. And just with, project one, you can work on any or all of the rest of the near-infrared wavelengths here. We'll give you kind of the starting points of the data, and you can go through of the pixels to light curves to spectra. Group project number two is with the MIRI eclipse spectrum. I was giving you the last eclipse of this MIRI phase curve, but it's a whole orbit phase curve. So you go from seeing the hot day side to the cold night side. And so, yeah, I'll give you that whole data set as a starting point, and you can go through and see, can you fit a phase curve? And it'll be a lot more tricky because there's a lot of systematics at the start here, which is why I gave you the second one. So it's a fun opportunity to see what actual data is like. Group project number three is going further with your work on PICASO. You'll kind of similar to number one, you'll instead of just looking at one near-infrared instrument, you'll try multiple near-infrared instruments, looking at it with a grid fitting tool and see, oh, does one instrument prefer one CO where C to O ratio while another prefers another, and try and understand, what is this ensemble of observations telling you about this planet? And group project number four will continue the work you did in petitRADTRANS, and it'll be looking, instead of a transmission spectrum, you'll get to look at an emission spectrum retrieval, in particular the emission spectrum observation of WASP-77AB, as was published earlier this year. And so I believe that's everything I had, so as a reminder, please go download the use the Google Colab notebooks, do the preparatory download thing so you save yourself some time. And then I think you'll get to choose group projects and start working on them later. So I'll take questions.
Taylor went over a lot of material, and before we get into the questions, the top presenters for today come down and please line up with the curve to like that, and so we'll try to wait just a second on the questions.
Yeah, no worries. They actually may have answered my question on Slack. Oh, you did answer my question. Oh, yeah. I'll just ask it again. Well, yeah, so. I guess-
All right, everybody. I think we've got the majority of the pop presenters here. So let's get on with questions for Taylor. Anyone's here in the audience? Don't, yes, there's one here.
Okay, can
Which time should we have decided for a group project? Is there any time at which we should have had signed up?
the question was, is there a time by which you need to sign up for group projects? Can one of the organizers comment on that?
Oh, yeah.
Okay, yes. So group projects. So the hands-on sessions, you don't have to sign up for those, the Monday, Tuesday, Wednesday hands-on sessions. Those you should just come back from lunch and we have leaders that will walk you through things. We have a lot of helpers, both online and in the room. People can't see me. So come back, you don't have to sign up for those. For the projects on, for the group projects that you will all work on Thursday afternoon, there are 4 different projects that Taylor just went through. You don't need to sign up right now. You might want to actually go through the hands-on sessions Monday through Wednesday to see what you might be more interested in doing. We suggest that during this week, you only sign up for one group project because on Friday, the groups will give short 10-minute presentations in the afternoon. We have space for a bunch of those. So the group projects, they're optional. They're usually a good experience though. It helps you actually learn what you're doing and it helps you to, some people haven't really given a talk in front of this many people before. So things like that. And it's a group presentation. So you don't have to take over the whole thing and give a whole 10-minute presentation yourself. You could get up and say one line or nothing and just support the rest of your group. It's up to you. All right. Does that answer the question? Yes. Okay. If you have, so you don't have, you can sign up now if you want. There's a